So, yeah, a couple videos I guess Gary had made. One got mailed to me, one I just was trying to catch up. Said he would unblock me, but he didn't. Said it didn't stick him where he's nice. Look, Gary, I just have to explain to you about the concessions and so forth. You have made concessions to me as well, because some of your rhetoric was like, you're a vicious criminal like Hitler because he had kids, and I'm like, well, what do you mean? I'm not gonna, obviously not gonna apologize for that. That would even be irresponsible, and you would agree. And you're like, okay, I would agree. I mean, I understand, grandfathered in. The point is, you admit it's a mistake or something. And I'm like, well, I won't admit it's a mistake. I'll admit that it was hormonal and it had to do with my own childhood. And, you know, I believe people are picturing their childhood when they picture having children. And so there's all that, but it's like, you know, that doesn't mean I'm going to say it was a mistake. It's like if I went to the movie, wander into the wrong movie theater, see a movie and I like it, but it wasn't the one I intended to see. I mean, that doesn't mean, like, yeah, there's a part where you say, yeah, it was a mistake, but it turned out great. And so sometimes those distinctions can be important. Like, do you regret going? It was a mistake, so don't you regret? Only logical if it was. No, I think some of mistakes are accidental successes or whatever. So the big picture there is that, you know, when people can have some base camps, and it's funny, I was using that term in another context recently. When people have a base camp, that's just one place that momentarily, in a corner of their philosophy, they found, look, there's an overlap. We both know how to camp in this spot. Doesn't mean it's our only camping spot or that all of our nutrients can come from there. Quite the opposite. When we leave that spot, we still go in different directions, you know? So when we agree, yeah, the world is fucked up, you still go back into, and therefore, let's just end it, it's never going to be fixed, and I still go back into, well, I'm still interested in fixing it. I think we should become anti-natalist when everybody is giving up trying to fix it, and then we can't kill the other animals, we still just have to be human ones, and probably humans will come back. So in a way that would be a cop-out, so it's hard for me to imagine wanting to do that. Okay. Now, one thing you said in one of the videos is about will. And I've said for a long time, I hope you remember or will acknowledge this, that I don't believe in something I would call freedom of the will. The word freedom is kind of a bullshit word we might as well get rid of, but it's such a great concept, and while we're fighting for our freedom, there's no way I'm going to spend my time, waste my time trying to get rid of this word, because it wouldn't be good to get rid of unless you replaced it with a better word. And the point is that freedom and those restrictions, it is true that they're linked. You said that the freedom is defined by the restrictions. Well, the restrictions are defined by the freedom you would expect to have, right? Like, nobody says the freedom to fall over and have excruciating pain anytime I want. You were talking about flying and reciting great works of literature and stuff, right? So the fact that you want to have freedom of that also defines, in other words, they're complements. It's like black and white, or light and dark, rather. You can define light as the absence of darkness, or dark as the absence of light. You can do this in the black and white kind of gradient. Now with photons and material, we find out, well, it's really the light that's there, because that's the material thing. That's called materialism, when you decide to go with materialism. But in the concept, there's still, you know, both ideas, and we use both ideas. It's getting darker, as if there's a substance of darkness that's filling up in a place. Because sometimes in the context that makes sense, regardless of the materialism, because conceptually we like these kinds of balances, and freedoms and restrictions go together. You know, separation and connection. It's like, I have a foot, that's your separation, it's also, in a sense, your connection. It's the medium that will connect you as well, that separates you. That one's harder to see, but maybe you can see. Or, and I think a psychological thing, a person's strengths are related to their weakness. If you're really strong-willed, then that's good. You're strong, you're going to not let people step all over you. On the other hand, you'd probably be an asshole a couple times. If you're really, you know, gentle, that's really good, but maybe you'll be gentle to something that to get healthy needs to, like, for example, if you're really gentle, so you can't put someone's you know, dislocated shoulder back in their socket because you just can't, you're too gentle to do it at all. So it's strengths and weaknesses, to be really intelligent and then to overthink things, or to be really athletic but you know, have a heart attack because you run 100-mile marathons every week. You know, there's lots of them, and sometimes even the fault is justifiable. I think in the sense that it's good to have a fault you can live with that's worth the price for the success. So there's a lot of things like this, and freedom is one of them. So I say that there's willpower, and that just means that there's a force will. It doesn't mean that it's not caused or anything. And that's kind of why quantum mechanics comes in, not because it's what will is made of as far as we know, but more because it gives us a better idea of what randomness, how causality and a real material randomness, not our old classical idea, which doesn't happen in nature, but this different idea that is material. You know, a weird thing about quantum mechanical randomness is it's not like classical randomness. Like in classical randomness, if there was an interchange of energy and there was a slightly random component, you wouldn't have conservation of energy. The total energy in the system would drift around. It could drift higher. In quantum mechanics, you don't have that. Any deviation from a conservation is very short-lived and resolves itself, like in, for example, in the bubble chamber in a collider or something. They don't use bubble chambers anymore, but you know, it resolves itself really quickly. Somehow the randomness keeps the conservation of energy validated. So right there, it's very different randoms. There is something synchronized, inherently synchronized, that satisfies what you're looking for in the sense that there's a rule. Okay, but when quantum mechanics, I wish you had understood Dynacat's video, because he didn't go too far. He described what classical physics was faced with explaining the random events. Now they've done all the collision kind of stuff, you know, like you were making a conjecture about. It's very logical, and that kind of thing has been looked into. One problem is that actually inside, let's say in a helium atom with a couple electrons, the electrons don't collide. They can't collide. They're actually in this field. They're in their waveform, and they make kind of like a soap bubble around the nucleus. That's why if it gets energized, it might go out to here and be a bigger soap bubble, and then when it collapses, boom, it shoots a photon off. That's how it works, you know? Okay, so it's like a soap bubble, and that's why there's certain distances that the bubble can be at. And the transition, it never spends time in between, really, as far as you can tell. Or it does, but it's sort of in the in-between time, so that it doesn't actually, it's in a quantum superposed state while it goes there. So it would be going there, but it would sort of be, you know, it's not able to interact with anything on that scale. So by the time it has to interact with something, it's, you know, it's at whatever other state. So it's discrete, and that's what they call spontaneous. Okay. So they don't even run into each other, and it doesn't. There is no model that ever worked. Now the thing about quantum mechanics, they're scientists, okay? They did promote a randomness, and that Einstein reacted to, but they were actually still looking for the rules. That's why Einstein didn't say you're not a scientist. Actually, Einstein helped Bohr because he helped start quantum mechanics, but then he didn't like the dice part. But maybe it probably isn't dice, but it's something else, and there's more randomness than maybe he was comfortable with, but maybe that would change if he understood a new kind of randomness. Now the issue is that they explained the probability a certain way, and they did some math, let's call it just math, so nobody's saying it was for real true, that assumed that, you know, probability was a wave, and it's traveling along, just in the math, right? Now that worked really well for predicting things, the weird enigmas, you know, but it didn't allow you to actually predict a unique event. You can say statistically there'll be about this plus or minus this amount, you know, in a certain period of time, but you can't be specific or when an event would happen. Okay, so is that sufficient? Not really. Everybody's still looking for something better, but the question was raised, is this probability wave material? Okay, it's an electron, it looks like a particle, it doesn't have wave properties. And what they were able to do with the two-slit experiment and a lot of other quantum experiments is to show wave-like property in those things. Now at the same time, you have from Newton on a sort of a similar debate from the other direction. Light tends to show wave-like tendencies. They could figure out those were, even though it's kind of weird, invisible, and very short wavelengths, you see the ripples and diffraction patterns. Those are wave-like patterns. You can recognize the exact same patterns playing with waves in a wave pool. So, was it really a particle? And they were able to show that it also, in a sense, had a particle. Now, that's the hard thing with light, because with light, you're going to produce billions and trillions of photons. The easy way to see that light is a particle is when you can slow it down, so you just shoot the photon one at a time. Dink, dink, and it makes a little spot, and that looks like a particle in its material. It's the same kind of thing that happened with electrons, but it's harder to understand something that normally acts, from our point of view, as a particle, as a wave. But it explains things like superconductance. Why? Because an electron acting like a particle bumps into stuff. There's stuff in the wire. But a wave can travel through. If you have a bunch of, there's places where they have weird piers and they've thrown big cement spikes in the water and stuff, and it could slow down the wave, but it also lets the wave through various, so depending on how far apart they are and the wavelength of the wave, it could just travel through something like that. That's a wave-like behavior. It's magical. It's tunneling through, they call it. If you think of it as a particle, you have to call it tunneling. When you think of it as a wave, it never did tunnel. It's just like a wave. A wave can slosh through some kinds of obstacles as if it wasn't there. And if you look closely at wave mathematics, it has to do and the spacing of the things in its waves, the size and spacing of them, and the wavelength of the wave. So when they see these wave-like things, that shows that it's material. It's not just the math, that there's a wave, there's an actual wave interacting. That's what it means, So that's what made them think the probability was material. Now, by thinking the probability was a real wave packet, that is a kind of determinism. It's just that of the whole wave packet, we see a cross-section. It's like we're living in flatland, right? So the many histories, Feynman's version of that term, approach, is saying that, yeah, we're living in flatland. We don't know what's outside of those dimensions. It could be virtual in some sense, but basically in his physics, in the Feynman diagrams, what you assume is that they're all happening. Maybe only one is really happening, the one we experience, but it doesn't matter. Mathematically, it's as if they're all happening, so it's like we're in a flatland. And I think when he called it many histories, it was better, because it isn't about the universe splitting. It's more like, okay, this could just be one universe now, but how could you get here? So in quantum particle collisions, you have, a particle could become from this to a pair of something different, right? Well, there's also a lot of different ways. It could do a lot of different things to end up in that configuration. In Feynman's kind of view, it does all of them. And the whole weird quantum thing is that if you look and make an event earlier in the chain, then you'll see a different part of the chain. It'll, of course, be a different chain. If you wait to the end result, the probability of the end result can be calculated by assuming they actually all happen, and then it's sort of resolved at this later point. Okay, so he didn't say many worlds, but it gives materiality to all those other possibilities, which you have to do. The material thing is this wave, and we're just seeing a a cross section, like we're in flatland. Okay, now on the other subject you were bringing up with will, the thing is, I see those things as well. Like you said, it's hard not to think of in terms of free will. And then you talked about, well, actually I can see how I'm impulsed by my subconscious. And that's how I feel. I've expressed this 1,000 times. None of you get it. Those of you arguing against free will, you don't even see, you should see this as a base camp. Because, yeah, I think we have tons of unconscious will. And besides, think of a control room. First of all, our consciousness is not our whole self, right? Right? We know we have unconscious parts, and the heart I don't think about. So obviously the conscious mind is a part of the body, and it's even just a part of the brain. We know that. Right. Okay. So, if it's in a control room, that's not command. These are not kings. You guys still think in terms of king controls. That's not how anything organic really works. Being in a control room like of a power station, you're getting information about what's going on. You could push a button that's supposed to lower the temperature, but it doesn't really lower the temperature. It sends a signal to a thing that turns on, that puts a system redundant, and then prepares and opens a valve, and then, all of this stuff is happening. And you'll have another screen saying it didn't work. And that's what it's like. We're just a little part, and mostly we could just say, I would request we go to the store and get me some beets. And if you're hungry, some other part of your body. So, to me, yeah, you know what? We don't create these or command. We're like sitting in a control room where we find out what's going on. And what's going on sometimes is like, let's say somebody falls. Let's say a kitten scares somebody and they're so scared they step back into the street and a bus comes and hits them and they fly off and land in some petunias. Okay, as seeing this, I'm reacting to it, and there I could laugh at the absurdity of it, or I could be concerned and watching the guy to make sure I could try to help or see if he survived, or be calling 911. Depending on my situation, when I see this coming, I can sort of direct between things like that. If I'm having both feelings, like, oh my god, I'm gonna laugh, and like, oh my god, this is terrible, in the control room, I can't say do the responsible thing. What I can do is just make a commentary, and then my unconscious will reacts to it. Okay, so I have the will to make a commentary. Some of the commentary even might be automatic, and there's some sort of recursive, similar thing going on. But I can, for example, I can say, wait a second, you guys, we're in a theater, and this is happening on a theater screen. Go ahead, laugh. I think that would be okay. I'm very likely to laugh. I'm in the street, and I'm going, dudes, this is really happening. This is not a movie. And I'm going to immediately, when I say that, the laughing part is going to go, oh, okay, wrong situation. Of its own accord, but I informed it. That's how it works. That's how it works.